Rahim. Today's lecture is about sedimentation, coagulation, and flocculation. These are the most important physiochemical processes uh, concerned with the environmental engineering, and they are taking place in different reactors related to our uh, wastewater treatment plant and water treatment plants. Mainly, it will be covering the process of sedimentation and furthermore facilitating how we can uh, help in the process of flocculation and coagulation. What is the basic difference between these two terms, coagulation and flocculation, and then how the actual process of coagulation is taking place. So some of the basic things, I think it's very much clear, basic terminology which will be involved in this topic, and then something about the conventional surface water treatment approaches, and starting with the screening, coagulation, flocculation, sedimentation, then filtration, and then disinfection, storage, and distribution. So I think it's just kind of revision. You have already uh, studied all these things in detail. One more thing I would like to add, that the process of sedimentation is very much concerned with the design of our reactors. For example, sedimentation tank and equalization tanks. In this reference, sedimentation involves the process of settling down of all the suspended particles. I think it's again um discussed in detail with in different courses before this topic, and I have also shared some of the notes related with this topic of sedimentation and its design about the sedimentation tank and equalization tanks, in which there is determination of the different dimensions and the settling velocities both. And again, we have applied Stokes' law in that uh, determinations, and how we actually used the buoyancy force and the gravitational force acting on a suspended particle, which is settling down to the bottom of the sludge. So I think these things should be clear, and I have shared the notes as well. I will also share one of the um, audio video uh, which I prepared for the bachelors, but it is again very much helpful to recall your previous knowledge. But focusing on this lecture, we are more concerned with the process of the physiochemical process rather than designing criteria and designing steps. So you will not find any kind of designing material in this slide. Only we will talk about is the physiochemical processes which are facilitating the treatment of water and wastewater. And again, in both the processes like flocculation and coagulation, uh, the most important thing is the uh, behavior of the colloids, and how they are actually working in within a solution, and how they are getting agglomerated, and how their size is increasing, and how their density is increasing, and how it is being facilitated that they may settle down in the bottom, and being removed from the reactor. So this is what I want to focus in this lecture, and I consider it very important with the reference to physicochemical processes. This is the most important topic. So uh, what actually this suspension relates, it is the settlement of the particles independently. But um, not all the particles have the ability to settle down. They need to some process through which they are forced to settle down. Sometimes the gravitational force is not sufficient enough to facilitate their settlement to the bottom. So um, the particles which are denser, they are much at ease to settle down because of their density and composition, but at the same time the colloidal particles remain suspended. And if we consider the particles which are having lesser uh, size than the colloids, then those particles are mostly existing in the solution in the form of dissolved particles. So they are existing in the solution as absorbed particles, so they are not facilitated in the removal unless and until we ionize them, we separate them from the solution, and then we uh, collide them with some other particles to increase their size and density and then settle down. So that's why those particles which are having a smaller size are usually existing in the form of dissolved form, not in any ionized form. So uh, for the time being, I will like to uh, explain that these colloidal particles are normally uh, existing in the form of uh, atoms or molecules paired with other atoms and molecules, and thus they are existing in a dispersed form. So that's why they are a part of the solution uh, which is in dispersion. Now if you check the particle size versus the settling time, you will see that the particle size starting from 1 millimeters and ranging up to the colloidal limit of about 1 nanometer size. So you can observe that this is the order in which the size is reduced, size is decreasing, and with this decreasing size you can observe that the time to settle is also decreasing, which you can observe here. And then again we have some other comparisons with settling velocities, and again here you can observe that as we move towards the lesser size, the settling velocity is also increasing many times. Here is a size comparison with what we are actually dealing with. Normally we deal with algae, bacteria, viruses, fungi, and different kinds of microorganisms, and then we have colloids, and then we have some dissolved particles, then we have some acids, some suspended particles as well. So you can see how the size is ranging. uh, so on the right side we can see there is an increase in the size, while on the left side there is a decrease in the size. Normally, the colloids have a size ranging from 1 micrometers to 1 nanometer. This is a typical size for a colloidal particle. And now some of the basic description about the coagulation.